Okay, so welcome to data science. Today we're going to cover chapter 4, which is data visualization. Last week we went over the data cleaning and processing. We used the Starbucks menu to do some exploratory data analysis, some preliminary analysis on what are the columns, how many rows we have, how many data points are missing, how many of them are low-calorie drinks, high calories, and we group them based on the average of the calorie value for each one of the categories. And then we plot very simple plots on a box plot and a histogram. So today we're going to start a new chapter, which is the data visualization, and I'm going to explain some more other concepts about the data that we need for conducting a more thorough data analysis. Let me do something here before we continue. Okay. Okay, awesome. So today we're going to see first what is data visualization, the importance, some types of data, the difference between visualizing the data and using statistics as we've been using so far, some tools, the visualization process, what are the steps to reach good visualization. I'm going to show you some common mistakes we make while we work in data science and how to fix them. I'm going to show you the errors, the mistakes in data visualization, and how to actually convey the message well, providing you some basic principles of effective data visualization. And then we're going to cover 2 examples, and there will be 1 exercise. Okay, so that we will use 3 different data sets. The TIPS data set, the IRIS data set, and one that is exclusive for this class, which is based on the Marine Robotics Lab. So first, data visualization is how we represent graphically the data that we are analyzing, that we are covering in our project or any other task that we're assigned to do. So any use of charts, graphs, and visual elements is part of the data visualization. And the goal is to convey some message, to provide insights, extract patterns, give meaningful information for those who need to write some policy, use the data to make some decisions. So the idea here is to make sure that these folks can get insights very fast about the data before they need to even ask questions or ask us to redo some of our analysis. So the goal here is to transform complex data set into dashboards. We're going to work with several types of elements to distribute across a dashboard, so it's easy for people to digest, to understand, and to interpret the data. Okay, so data visualization is important to find patterns, trends, relationships between the parameters. Remember that we are using CSV files, tables, or data frames, where each column is a different parameter. So we use data visualization to immediately check for some relationships that raw data is not, using the raw data, it's not so easy to find. So visuals are very engaging. It provides a story about the data. So when you're presenting something with data visualization, it's easy for you to create that storytelling, to tell the story of the data and produce the results and produce the outcomes. What does the data is telling you? So it simplifies complex idea and make them accessible to a broader audience. And that's one thing that I've been learning at FIU for many years, is that you need to make sure that the data is understood to a broader audience, not just people that are in your field. It has to be easy for people outside your field, outside your bubble, to understand what you're presenting. So sometimes the simpler is better than if you want to provide some fancy ways of showing the data. The simpler, the better. And we'll see that very soon with some examples. So data visualization helps us make decisions with clear insights and help the stakeholders, whoever we are presenting it to or whoever asked us to do that data visualization, to see the outcomes or the consequences about that data. As we've been discussing since day 1 of class, data is being produced at unprecedented rate in all domains. There is no single domain where data is not being produced. And we have more data available now than we have capabilities now to process them. That's what we call big data. So we have even to select what type of data is useful for us, because there are so many new things being generated, and they are usually not structured. And we studied that in the second week or third, I think was the first week of class, where unstructured data is way more present in real life. Around 80% of all the data that we produce are unstructured, so it's not in that format of tables. So turning unstructured to structured takes time, and that time is important because new data is being generated. So the time you spent structuring your data is time you could have spent processing the data, so that once new data sets are available, we are ready to analyze them. So it's a very complex process, and the idea here is to provide a streamline, provide a clear guideline on how you should process this data. So that's a part of data visualization, is part of this process. So the first thing we need to do is this exploratory data analysis. You may find EDA, it stands for exploratory data analysis, is this early understanding of the columns, how many rows we have, if it's temporal data, what's the type of each one of these parameters. Are they numerical values? Are they simple text? Are they categorical? We are gonna explore them very soon. Hypothesis testing, which is topic for next week. We're gonna use visualizations to help us test the hypothesis and validate, assuming that the data analysis will draw and will reach some conclusions. So when we use hypothesis testing, having good visualization for the data we are trying to validate makes the process much easier if we are just using raw math, raw numbers and math. We use data visualization for presentation, reporting, in any scenario, in any field. I cannot think of any field that presentation of data, storytelling, and reporting is not present. And storytelling is how that data, from the time that the data was collected till the insights you get from the data, how can you tell that story in a way that it's engaging for the public and it provides insights, highlights the important aspects, patterns, trends, or use it for some forecasting. So first, let's analyze the types of data. And I'll ask some questions very soon about, there will be an exercise here and a discussion. So the first type of data that we need to understand is the categorical data. And it's very simple. You have several categories, okay? So a category can be low calorie, high calorie. A category can be a country. Anything that you can group is categorical, that you have a label, okay? And it's not easy to be, I think several students are joining, so I have to admit them to the... So it's not easy to count, to quantify those values, because they are simple labels, right? The name of something or a category. So it's easy to group them. That's good. It's used to create distinct classes. So some examples, simple examples that we can think of: gender, colors, types of animals, species, product categories, different sorts of currencies. And we also have the numerical data, which can be measured. So they are usually numbers that we can measure, and we can divide them into two categories, subcategories. We have the discrete ones, where you have whole numbers, usually for quantities, where you can count 1, 2, 3, 4, 5. Okay, so the number of customers, the number of students, the number of classes, the number of sections available, the number of campuses, products. Or continuous. The continuous numerical data is values that are in the float range, the decimals, right? And we use that for height, weight, temperature values, salinity, dissolved oxygen. So now for all the parameters we're going to study in this course, we're going to have to classify them into these different types of data. There's one more classification, the time series one. So time series is a specialized column that we use to when observations are recorded over a specific time interval, right? Or chronological order. That's the one that I deal with the robotics, because as the robot moves in Biscayne Bay there on the surface of the water, it collects data every second. This every second means that I have a specific time interval where the robot is going to measure some properties of the water, okay? To extract the quality and the health of the bay. So I deal with time series or temporal data. It's commonly used for tracking changes or trends over the data and includes the timestamped data points that can be numerical as well. So let's do an exercise here. I have here this data set, a simple one with 5 columns. So we have here 5 parameters. We have country, population, continent, GDP, and year. So I have here continuous numerical, time series, categorical, discrete numerical, and categorical. So I'm going to ask, and I'm going to check which one is the parameter country. Which one do you think is the type of the country data, the column that represents country? How do you classify the country parameter?
Categorical.
Categorical. Very good. How about population?
Numerical.
Which numerical?
Discrete.
Discrete because you can count, right? I can count the number of individuals, the number of people living in that country. So it's a discrete one. How about continent?
Categorical.
Categorical because I can group them in different continents. How about the gross domestic product? The gross domestic. Continuous numerical. And finally, the year is, in this case here, you can think of it as a time series. If depending on the analysis, you may also use it as categorical. So it depends on the application. In this case, here is the year. So some discussion time here. So I'm going to give you some time to think about these questions here. And I'll check. There is one student that said that they could not log into Zoom, and I'll see what happened, and I'll be back. So the question here are the questions. Why do you think visualizing data is more effective than presenting raw numbers or text? Can you recall in other classes or in your research project where data visualization played a significant role in conveying the message or making some decision? Or can you think of other examples of categorical data in your daily life, in other classes or in your projects and research? And why is time series data important in fields like finance, weather, and sales forecasting? Okay, and let me see what happened with the student that tried to log in. Okay, anyone would like to start to give me an example of some type of categorical data or a situation where data visualization was important in your field? Anyone can recall? Think about the data you collect for other courses or for your research. Anyone in ecology can give some examples?
So I think data visualization is better because when you have a lot of data, put into a graph, and you could check where in specific
You
is
can
it, or
summarize.
see it, yeah, or see it over time.
Very good. Okay, I see. Go ahead, please.
So I know when I was in ecology, there were a lot of charts and tables showing information, which I found it easier because like you could see correlations within data rather than just talking about it. So like I rather visualize that, hey, there's a correlation between like temperature and ocean acidification or something like that. And you
Mhm.
can see that when one goes up, one goes up as well, or goes down, it goes down as well. So kind of like the correlation is better to visualize through visual representation.
Very good. I see when there's too many things being measured, maybe it's too busy and messy. So a graph is easier to read, allows you to see trends and make it more easily digestible for those who do not know what the data means. Very good. Okay, so let's continue. I think the student was able to log in. This link is through FIU, so all FIU students are able to connect. And again, it's being recorded. I'll also put this in Canvas. Okay, moving on. So based on your answers, now we can differentiate between the summary statistics, pretty much that describe method that we use in Pandas, from visualization. So when we talk about visualization, it involves representing graphically through charts, some plots, some maps, right? Maps is also a great way to visualize data that is spatial, right? That is collected through latitude, longitude. So it's provide this visual overview, making it easy to spot, to identify trends, outliers, patterns, and it's effective to explore and understand. The summary statistics, on the other hand, involves more numerical measures that provide insight on tendency, spread, shape of the data distribution. And you use this so that you can select what parameters or data set you're going to use for some prediction or forecasting. So summary statistics is very good for selection of the data that you use as input for some forecasting or prediction of a certain trend. Let's say if the real estate market is going to go up or down, if prices will eventually fluctuate, if the currency exchange rate will change. So you use summary statistics to choose what the best components, the best parameters will be for some analysis. Obviously, visualizing the data can also give you some ideas. You can look at it and spot some that might be good, but you need the summary statistics to make more informed decisions. So some advantages of data visualization: it's quicker, it's more intuitive to find these anomalies. It's easy to communicate through visualization through a larger, broader audience and make data more accessible, right? It can reveal some patterns, hidden patterns that the raw data or the statistics might not give you immediately right away, but there are limitations, right? Different individuals may interpret visualizations in a different way. So then you can say, okay, my goal was not that, but that's what the audience understood. So the limitation of visual aspects is that different people can understand the data differently. And that is something that is a huge discussion that summary statistics would not provide. So by looking at summary statistics, everyone will see the same number, will understand the same average, the same standard deviation, and to use in forecasting, also you have an outcome and you can calculate the error. So it's something that people can say, oh no, I don't believe in this error. Well, you can do the calculation yourself and you see that the prediction error was such, right? But through visuals, if you're trying to visualize that, that might be trickier because people might understand them differently. And also there is the problem of data overload. Maybe you're trying to come up with some dashboards that is way too cluttered, and the complex visualizations might actually harm the understanding of the data if the users cannot extract any meaningful information from it. For data pre-processing, creating effective visualizations may require more data pre-processing and cleaning. It's what we learned in the last 2 weeks. The advantages of summary statistics is that, as I mentioned, you can use it for more complex models for forecasting predictions, right? So you can provide precise numerical numbers, so you can use the parameters you need, and you're using precise numbers that are easily verifiable, unlike visuals that you cannot easily validate. So used also in statistical testing. Any statistical testing would use the numerical values you found in your summary statistics. For comparison, as I mentioned, choosing the best data sets or parameters for some prediction is also better to use the summary. Some limitations, laws of data. So you may have some aspects of the outliers that is not captured in the summary statistics, but you can see that in a box plot. So in some visualization, you might easily see some outliers, but those anomalies or phenomena might not be easily caught using summary or the raw data. It's insensitive to outliers, as I just mentioned, right? The outliers might be mixed with the other numbers, so they might interfere with the overall average and the standard deviation. So summary statistics might be sensitive to the outliers depending on how you collect the data. To visualize, you have several tools available online to visualize the data. Since we are using Python in this course, Matplotlib is the main one, is the standard one, and in fact is the one used for other more advanced, is the one used as foundation for more advanced visualization tools. Python has one called Seaborn that is very user-friendly and very pleasant to look at. And one of the most robust ones that we have in Python is called Plotly, because it has almost all possible ways to visualize the data with just calling a function. And that's the one we're going to use. And that's the one most people use for mobile apps and web applications. And that's the one we're going to use in this course. There's also Tableau, which is very popular in business intelligence when the focus is more shareable, interactive, and industry-based data sources. Okay, so we're going to use Python. It's widely used programming language for data analysis and visualization. Some of these tools also work for R, because I know some students mentioned R to me. So I mentioned it here so that you can also try to visualize it in R if you use R for your projects. And in some Power BI, I know some students use Tableau, especially in the business department. So all these visualization also work with those frameworks. So it doesn't have to be just Python, okay? So what is the visualization process? Starting from the data acquisition, make sure that you consider all the ethical aspects of how you're collecting the data. If you have significant population, if you have significant, if you're collecting data through a significant amount of time, right? From various sources, different APIs. Remember, I briefly mentioned APIs last week, which is how you get data from other companies, is how companies make their data available to you for their own profit, and obviously for you to use that data for something meaningful to you. An example of API is how Google Flights website has the current price and availability of tickets of American Airlines, Spirit, Frontier, Delta. It's because these companies provide their API to other companies so you can access their data. So API is how one application, one software, one website communicates with another and transfer data across the web. So that's a way to get data. But you also have spreadsheets. If you have a device, an instrument that collects data, that instrument might give you the data in a spreadsheet, for example, in a CSV file or some database format. And as we discussed in the first week, that data might has to be clean, hopefully with no missing data. Otherwise, you have to take care of that during the pre-processing phase. And hopefully it's well structured with headers, well-defined, and at least a minimum amount of rows, which are observations that are meaningful for your analysis, that are relevant to your analysis. And then we provide the data cleaning. It's handling the missing data, making sure that all the formats are known, right? All the data types are known, if it's true or false, if it's a text, if it's a number, if there's no duplications, and if we need to group them to make it an easier process of analysis. And then we go for the exploratory data analysis, pretty much understanding the characteristics of the data set, the patterns, and involves what we did last week with the summary, the descriptive statistics, and visualizing it. It's what we're going to do today, creating histograms, scatter plots, and discovering some insights about it. During this phase, we can also see some outliers. Remember, we saw briefly some outliers in the Starbucks menu example, identifying some trends as well. So from that point, now we design our visualizations. We choose the best ones, and I'm going to show some examples soon, like bar charts, scatter plots, heat maps. Then we build our visualization, our dashboard. We like to call it dashboard, and then we build a story from understanding where the data was collected till conveying what that data tells us, what information it gives to us. Okay, it's always good to have some visualization that shows that path clearly from the data, how the data was gathered, all the way to the insights, and give the stakeholders, whoever you're presenting to, a chance to ask information about the data, give you feedback. You can test your visualization tools. Maybe they were not effective, so you can fix it for another presentation. You can add some interactivity to visualizations. For example, if you hover the mouse over some parts of the charts, it tells you more information. You can change the colors, or you can make the colors meaningful. In a line plot, for example, you have the x-axis, you have the y-axis, and it's telling you the how y changes according to x, correct? But the color of that line might tell you a third parameter. So you can use the color for that line to show information about another parameter. For example, in my case, when I'm dealing with the time the robot is moving and the temperature for each one of them, I can use the color of that line to show how the oxygen level changes. So this type of interactivity gives extra information. Of course, we have to be careful not to clutter and provide too much information at the same time. Then we craft a compelling data story. Don't forget to include ethical responsibilities, all the ethical aspects on how the data was collected, avoiding biases, being transparent. So some common mistakes that we have in data visualization. So some chart or graph that you use misrepresents the data intentionally or unintentionally. Example, you truncate some x's because those numbers will give a bad outcome or some bad consequences for what you're presenting, or it's saying otherwise. It's saying something contradicting to the message you are conveying. So truncating data is something we should avoid. The data is telling us important things. If it's not good, if it's not desirable, it's still valid. So once we understand that even if it's not good, it can be valid, we can provide a better visualization. Inconsistent scales, I'm going to show you some examples. Or, and this happens a lot, trust me, cherry picking data points. So choosing just points that will validate what you're saying or confirm what you're saying and bias towards the message you're conveying. So cherry picking data points is also something we should avoid. Any questions so far? No? So how to avoid this? And any questions? So make sure that in your projects, while you are working on some data sets, make sure they are accurate, they came from reliable sources. Critically assess the visualization before you present it. Try to find yourself some biases. Today I discussed with some other professors how difficult it is to identify biases, because a lot of news and articles you see online and videos about data science online is all about how do you remove bias? How do you make sure there are no biases, right? First, you need to learn how to identify them, and that's the trickiest part. Once we know how to find them, then we can come up with ways to remove them. But first, we need to learn how to identify them, and people are skipping that part. They are assuming we already see the bias and data distortions. So another common mistake in charts and visualization tools is poor color choices, right? Inappropriate use of colors that can lead to what I just mentioned earlier on, confusion and misinterpretation. So maybe the colors, the contrast is not good. It's difficult for you to distinguish between the data categories, and it can create unnecessary distraction. So you'll need to learn color theory for that. Ignoring the audience, right? Who you're talking to. Get to know the users of your dashboard, or get to know the audience or the stakeholders you're presenting to. Understanding who they are beforehand might help you avoid many of these problems, okay? On backgrounds, the colors, and the preferences. So situations where visualizations fail to resonate with the audience due to inappropriate content or complexity, right? So get to know who you're presenting to. Have audience awareness before creating. Determine who the audience is and what they expect from you when you're visualizing it. Overcomplicated charts, right, with excessive details, unnecessary complexity that hinders the understanding of the main message. Charts with too many data points, intricate annotations, or cluttered visuals. So opt for the minimalism. The less, the better, usually when you're dealing with dashboards and visualization. Focus on the core message. Promote decluttering. Let me see here.
Sorry, someone has their mic on and I'm hearing a lot of background noise, so it's kind of hard to hear you.
Okay. I think it's solved. I think we covered the overcomplicated charts. So some examples. Look at this one. This is a real example with countries. So you can see that the pie chart was used here. Too many colors. What do we need all those colors, right? They're not meaningful. They're not giving me any information. They're just a style here. But honestly, no one can possibly look at this and understand the different colors. They might not even be able to name these colors. They might have more questions than answers. So pie charts are useful when there are at most 5. This is a magical number we use for pie charts. If you have more than 5 parameters, pie chart usually is not the best option. Okay, obviously, there are exceptions. I'm just giving you a reasonable amount of parameters that you need to use and convey the message effectively using pie charts. In this case here, this is a real example where I can see that you have USA with a large blue circle, you have Brazil with the orange one, and they change in size. But what is this conveying, right? If I don't read the text, this plot here doesn't mean anything. So it's missing at least one extra label here to understand what it's trying to convey. So what is this? Population? Some gross product value here. What is this trying to show? So easily it's missing some labels, right? It's oversimplistic, and in the case that it's making the user look at the text to find more information. And now it's the opposite, too much information, right? So here I have a map of the United States separated in West, East, Central, and South into regions, right? There are too many colors that clutter the dashboard, a lot of different lengthy text that the user, massive number, geographic shapes, some colors, right? So remember that colors have the power to evoke several emotions, right? Positivity, trust, strength, confidence with the audience. So make sure you keep the colors in sync with the company's brand or the message you're trying to convey. Standardize your color. If you're showing the USA in blue color, make sure that throughout your storytelling, throughout your presentation, you use that color to represent the same country. If you're using orange for another country, use that same one for all the other charts throughout your presentation. So this is a case where I see it's about sales in Superstore, but you see the message is not conveyed easily. It takes a while for the user to look at this and extract meaningful information. So here I show the same data set in 2 different ways. One that is ineffective and one is effective. And why am I saying that? You can see that the right side visualization, which is good here, simplifies the comparison. So you can see that for Central, you have furniture, office supplies, and technology. And just by looking at that bar, you can see which one has higher value and which one produced less, right? Had less sales in that category. But in the previous one, it takes a while for you to visually see which one and where that is, right? So you have to look at, first you look at the central, then you find the category, furniture, office supplies and technology. And then once you identify that, you go back down and look at the number. So you can see how the one on the right, just by looking at it, the audience can see, check the number, and see which one had the highest sale. You see? Another example here is, again, the pie chart. It feels like I'm advocating against the pie chart. That's not the case here. It's just because sometimes when the numbers are too close, right? In this case, you see, it feels like they're almost too close to each other, but they are not. So pie chart is not the way to go, because by looking at the colors, you might not get a sense immediately of which one is the largest one. But if you look at the one to the right, you see that technology is the one that had the highest sales. But you cannot get that information through the one in the left easily. It takes a while. Any questions so far? No? Another example with maps. I love maps. So the message you're trying to convey here is total sales. And you're using this green scale here to see where you had more sales than the others, right? But you have the labels of each one of the states. If you're here in the United States, most people know what each state is. You don't need a label for each one of them. It's not giving me extra information. The message I'm trying to convey here is which states had the highest total sales number. And it's kind of useless at this moment to name them. It's deviating the user from, or the audience from, the real color shade that it's used to represent the total sales. So you don't need those. Another example of misuse of colors, right, is profit by year. Why am I saying the left one? I'm using this example that says that the left one is ineffective. Because the colors here, the message I'm trying to convey here is that in 2019, we had the best profit year, right? I'm focusing on that one. I'm saying that everything before 2019 was worse than 2019. So 2019 was the best. Why do I need to provide some random colors for 2016, 17, and 18? It's not adding anything to the message, to the information. The information here is, there's only one thing I want to say. 2019 was the best. I don't care about what the numbers for the other ones are. I'm not categorizing them. I don't need to label them anything. So I don't need colors for them. This happened to me many times. It's about, this is the average days to ship something. So you see that it's the same data set. But if someone looks at the one to the left, they immediately, most people would think what? Oh, the days to ship went down, right? Drastically. It's like a dramatic drop in shipping times. But if you notice, the issue here was what? The values you put in the range you use in the y-axis. In the one to the left, it starts from 390 to 4.02, which are not very far from each other. It's still around 4, right? So if you visualize it from 0 to 5, you see that they are all in the same range. They are all within the same threshold. So you see how the same data set, the same numbers can be visualized in two different ways. And the audience will look at the first one and say, okay, huge drop. But it was not. That was not the case. It was slightly a drop. This was like a minor. It doesn't even count as a day. It's a 1/10 of a day. Okay? Any questions? I think I have something here in the chat. Nope. Another one here. It's all about the message you're trying to convey. So you're comparing 2019 sales per month to the third year average, right? The one in the left, it's cluttered, it's challenging to read. You always have to keep switching, right, between the green and the gray to make sense of it. So you start noticing, okay, in January, green is larger, okay, but if you look at the one in let me see here, for example, in March, they're almost the same. So if you want to really compare these two, 2019 and the 30-year average, a better plot would be two line plots, right? One for 2019 and the other one for the 30-year average. So it's simple, it's simpler than the other one. It simplifies the comparison because you can look at both at the same time. You don't need to keep switching between one and the other. You see both at the same time over those months. Okay, so some basic charts that we're going to use. The first one is the bar chart. Okay, so the bar chart, it's used to compare values and categories. We usually have some variations for it, which is the vertical, the horizontal, and the stacked bar charts. So in Plotly, you can see that you can create beautiful bar charts. I hope you can still see my screen. And you see that with few lines of code, you're able to generate meaningful bar charts, and we're going to use them. We're also going to use line chart, like the one we just showed in an example, and it's great for changes over time, like the robots that I use to collect data in Biscayne Bay, or showing trends. We're also going to use some of the Plotly ones. So you can see that with few lines of code, you can generate line plots. And you see, comparing two countries, for example, just by looking at it, you can compare. So it's used for comparison and changes over time. We have pie chart, which, trust me, I like them, but they have very specific reasons to exist. So they are usually used for displaying parts of a whole, highlighting proportions. So you can see here that this one already has some violations of data visualization because I have more than 5. We don't usually use. This is a good example where we have 4 categories, so it's easier to check the differences between them. And you can stylize it in different ways. Another plot that we're going to also use is the scatter plot to show relationships, correlation between two variables, and you see if one increases, the other increases or decreases, or there's no correlation between them. Also very simple to do using Plotly. We're going to start very soon with it. We're going to use histogram for distribution, so to see if it follows a normal distribution or not. I think the histogram one, okay. So you see histogram, also with a few lines of code, we're able to use it. Box plot, even though I provided a simple example last class, we're going to do it in more details in data visualization. So it's used to represent the distribution and the spread of the data. So here it's going to divide our data points into quartiles, right? Into quartiles. So you're going to find the ones that are below the 25%, below 50%, and below 75%. So we're going to have that quartile range well defined, and it's very useful to find outliers, right? To find numbers that do not fit into the spread of the data. So think of quartiles, if you study this in statistics, right? Think of quartiles as a type of percentile, right? The first quartile, or also called Q1, or even lowest quartile, 25%. So it means that the data, the 25% of the data falls below this threshold. The second quartile, or Q2, or median, depends on how you want to call it, 50% of the data fall below that number. And the third quartile, Q3, or upper quartile, 75% of the data falls below that one. Just a review here. We saw that with pandas, it's easy to plot, but with Plotly also, you can create some box plots with a few lines of code, okay, where you can easily define the outliers, the maximum value, the minimum value, and the quartiles. Very, very beautiful. And finally, heat map for comparison, correlation, how one parameter or each parameter compare with the others. We also used it last class. We're going to continue using heat maps. We can do it in Python as well. So let me show you. So you see, you can easily create some heat maps. You have a matrix, you can simply call ImShow, and you generate it. And then you can stylize it, put some customization to it. These are the main ones we're going to use in this course and that I expect you to use in the projects. However, there are more. So if you need any other type of plots, Plotly has it. Don't worry, it has most of the charts available to you. So I listed them here, even though we're not gonna use them exactly. So the first example we're gonna do, now I ask you to open Google Colab, right? And maybe you can put me in half of the screen and the other half is your own Google Colab, and we can write the code together. It's gonna be the TIPS dataset. It's a very famous, popular dataset when we're learning data science. And it's going to be no different for this data science course. We're going to use this. It's some information about restaurant bills, where it has the value of the bills, the tip amount for each one of them, the sex of the person paying the bill, how many people in the party, right? How many people were together paying for that bill, when the day of the week that bill was paid, and if it was whether lunch or dinner. That is a very popular data set that we're going to explore. And that's going to be our first example. Then we're going to move to the second example, which is the IRIS. It's famous for machine learning and AI. The IRIS data set is probably the most famous data set when you're learning AI, artificial intelligence. So it contains measurements of various characteristics of 3 different species of flowers, right? Setosa, versicolor, and virginica. I'm not sure how to pronounce these species. So the measurements include the length and the width of petals and sepals, okay? And it's usually, as I mentioned, one of the main data sets when you're learning AI and classification and prediction. We're going to use it for example number 2. And for example number 3, which is also an exercise, because I'm not sure we're going to be able to cover it all, we're going to use an exclusive data set from iRobots that we collected. And hopefully we're going to collect this semester still in Biscayne Bay. And we're going to use it for our third exercise. So that's it. The introduction to data visualization. I know there is a lot of information to digest here. I'll make sure to post this to make sure this updated presentation is in Canva so you can use it as a reference. Okay, do you have any questions? Can we move to Google Colab, or you have any questions on these topics? So let's create a Google Colab that is going to be called Chapter 4, Data Visualization, Example number 1. Okay, so what I'm going to do is open my Google Colab. So for this first one, we don't need to download any CSV files. So we can go to our Google Drive, and we're going to add a new Google Colab. Google Colab, and I am going to call this one. Notice this file name is wrong. Okay, so this one is going to be Chapter 4, Data Visualization, Example 1. Okay, I'm giving you some time. First thing we do is we're going to import Pandas SPD, our main framework to deal with tables, and we're going to import Plotly.express as PX. So Plotly is the framework we're going to use for data visualization, and we're going to use the Express version, okay, so that we can write few lines of code to generate meaningful charts. And we're going to give a nickname PX. So we have PD and PX. PD for the table manipulation, PX for the data visualization. Remember, Pandas we've been using now for like 3 weeks. Okay? And we're going to have our first data frame. As usual, I'm going to name it DF. You can name it differently. And we're going to call from PX data, we're going to call the TIPS data set. Okay, so I told you it's very famous, so it's included. in Python, in R. R is included in R as well. In some R packages, you can get the tips. Let's do some exploratory analysis here. So let's see the shape of this data set. It's connecting my Google Colab. Thought it was already connected. Okay, so there are 244 bills, right? The observations over 7 categories. So let's take a look at some of these categories. So let's see what parameters do we have. So we have the total bill, the amount of the tip, the sex of the person that paid for it. Oh, if the person is a smoker or not, the day of the week, the time, if it's lunch or dinner, and the party size. Okay, this is a very popular data set that is already included. And let's see the first values here so we can take a look at the data. So if we do here head, we're going to get the first 5 elements. Okay, so you see $16.99. So this person paid $1.01 of tip. Female, non-smoker, it was on a Sunday, it was dinner, and there were 2 people. Any questions on the data set? Can we continue? Let's get some information on what the type of each one of this data is. So if we get the info about this data, the total bill and the tip are decimal values, float. The other ones are objects, probably some category, right? Or string text. And the size is an integer, right? So it's discrete. I can count the number of people in the party, but I cannot count what? The total bill and the tip. Great. So we know how to classify each one of them here. Let's find what days are unique. So I'm going to access the column day. So if I print this, it's going to print the entire 244 values. But I just want to know which values are unique. So I'm going to show you now that you have this unique method that shows just the different values. So this is what I mean by group. We used group in the Starbucks example. So here are the different values. So there is Sunday, Saturday, Thursday, and Friday, which means that we don't have data for the other days of the week. Vivian, the data is, it comes from the Plotly. It already comes in the package. It's used all over the world in data science. So it's already included here, you see, .tips. So when you do this dfpx.data, tips is one that comes with it. It comes as a sample data set. Okay? So it's a sample data set. It's a popular data set named tips. Okay? So the unique values are this one. So in your report, you can already say, I don't have data for Monday, I don't have Tuesday, Wednesday, but I have the other days. Let's see, for example, the unique values for time. So I'm going to do df time dot unique. Dinner and lunch. Okay, that's it. I only have dinner and lunch. Let's see one more here. The size. Unique. So there are only parties of 2, 3, 4, 1, 6, 5. So you might ask me, Greg, why is this not sorted? Because this unique is going to look for the first 2 and give me 2. First 3, give me 3. So it doesn't sort it. It just gives me in order they find it. So in the data set, starting from 0 all the way to 243, it saw a 2 before a 3, before a 4, before a 1, before a 6, before a 5. But there are only these numbers representing the party size. So which means that there is no party of 7, right? There's no party of 8. That's what it means. I only have party size of these numbers here. Second, what we need to do here is describe the data. So I need some descriptive statistics. So if I describe my data set, I know that there are 244 observations. The average bill is $19.78. It's a cheap restaurant, right? If the average is $20, tip average is $3. That's not nice, right? The size, on average, 2.56. And here you have the standard deviation and the quartiles. That's the descriptive statistics. Let me see if there are any other questions. No. So now, how do you calculate the average tip per person? So what I want to do in the next one is, can anyone help me calculate the average tip per person? How can I do that? Let me first create a variable for it. So, and let's do a column actually. Let's add a separate column for it that I'm going to call tip per person. And I'm going to do in this column, I'm going to divide the value of the tip. I'm going to divide it by the party size. Right? So when I do that, let me take a look at my DF. Look at that. I added another column called tip per person. And what I did was I divided the tip by the number of people. So on average here, the tip was 50 cents. I created a new column here. Yes. Now we're going to do what? We're going to get the mean of that one. Just get the mean of that column. So that column I just created, tip per person. No, not describe. I want to get the mean, which is the average. So the average tip here is $1.21 per person. Okay, per person is $1.21. I think that's some interesting insights we're getting from this data set here, right? Let's say, for example, we want to analyze here. I'm going to write as a comment the percentage of tips that are greater than, what's the minimum tip we give in Miami? 15%. So the percentage of tips that are greater than 15%. So let's see, out of the 244 bills, I want to get the percentage of these 244 that were greater than 15%. How are we going to do that? So let's access our tip. Let's create, like I did in the previous one, let's create a tip percentage. Okay, tip percentage. And I am going to get the value of the tip, which is called tip, is this column tip here. And I'm going to divide it by the total bill. Okay. And I am going to multiply it by 100 so I get the percentage. So if I want to check how the data looks like, okay, so in this first one, the bill was $17, the tip was $1. So the percentage here was almost 6%. So this person gave 6% in tip. I see this one here. So this person, $239, the bill was $29. The person gave $5.92. So that represents 20.4%. Okay, so the tip was 20.4%. But my question is, what's the percentage of all these that are greater than 15? Okay, so I see some here, 16, 16, 13, 14. I just want to find out of these ones, the ones that are greater than 15. You can use a different threshold. I'm just assuming data from today here, right? In Miami, I think is the minimum number tip that we give. Catherine asked me, do we have access to these files? Yes. So here in the beginning, in line 4, data.tips gives me access to this sample data set. It's a very popular data set to study data science because it has categorical data, numerical, continuous, discrete numerical, and many categorical values here. So as soon as you do px.data.tips, that df is going to be that table. Remember that Plotly is the package or library that we're going to use for data visualization, package for data visualization. And Pandas is the package we've been using for data frames or tables manipulation. Okay, so we use this for chapter 3. We're using this one for chapter 4. Notice that I'm always adding one package per topic in data science until we build a robust dashboard, robust data analysis. So this data set comes with it. It's a sample one. Okay, I'm adding some columns here because I want to do some analysis on the tip. Okay, so let's find out now that we have this column tip percentage. Let's try to find the number. So I'm gonna access here in my data set. You see, in my DF, I want to get the percentage, the tip percentage. I saw it somewhere. Tip percentage, okay, that is greater than 15. Okay, so it shows us here 135. So it filtered our entire table into 135 rows. So these are the ones whose tip percentage is greater than 15. So you can see here that it removed observations, for example, 0, which was 5.9%. It removed 3, which was 13. It removed 4, which was 14, just by filtering the data. So how do I filter the data? Given the DF, which is the entire table, I want to access only tip percentage that is greater than 15. How about greater than 20? Probably way less than 135. Yeah, much less. Anyone 30%? Oh yeah, you see? Okay. So this person here, 172, the bill was $7.25, and the person gave $5 in tip. That represents 71% tip. Okay. So here you can filter the data. And you can count. You can use the count method, which I believe you already used, to count the number. So we have 135 bills whose tip percentage is greater than 15. Okay, so there's so many things we can do here. And what's the number this represents, right? So this is what we're doing is the amount of, or the number, right? The number of bills whose tip percentage is greater than 15. That's what we're analyzing here. If you want to get the percentage, so you can do this, right? You can get the count and divide by the number. How many entries do we have? We have 244. Or you can do this. You can do the shape. Actually, you can multiply this by 100. I think it's better. And okay, so that represents 55%. So I'm just calculating the percent. I'm dividing by, remember that shape up here gives me the number of entries. So I'm just getting that number here, 244. I'm multiplying by 100, so I get a percentage number. So this means that 55% of the bills, right? 55% of the observation of my data had tip percentage greater than 15. Okay, so it's slightly more than half of the bills paid at least 15%. That's what it means. Okay. Sounds good? Any questions here? Let's do some grouping, right? Let's do some grouping. I remember I did a group by in this previous example last week. I think we grouped by average of calories here. Category, calories, mean. We group by beverage category and beverage. Let's do some group by, because I remember some students, a couple of students asking me about the group by after class. I remember having some questions about it. So let's group by, for example. Group by smoker. Let's use that interesting column on the smoker group. So it's going to be group by, okay, and I'm going to group based on the smoker. And what do you want to do? Let's see the average tip for them. So I want to access the tip and the average, right? So let me see the average per group. There are only two, right? If you're a smoker or not. So if you're not a smoker, the average tip was $2.99. If you are a smoker, $3. So it's well balanced. The tip by smoker. Let's see if it varies by day, if the tip varies by day. So how can I analyze that? So let's group by day. So DF group by day. It's a very smart. Google Colab is very smart. So group by day, I want to do the tip and I want to get the mean. So what's the average per day? So that's what I want to do. I want to, for each day, I want to get the average tip. Categorical data. Okay, so Friday, the average was $2.73, Saturday, $2.99, Sunday, $3.25, and Thursday, $2.77. So Sunday has the highest value of tip average, right? Is the average here is $3.25. So based on this data set, we can say that on Sunday, people tipped better. On Sunday, okay? How about dinner or lunch? Which one gave a higher tip? So how can we do that? So if you want to do group by time of the day, we're going to group by time. And I want to access the tip average. You can add the total amount as well. So let's do, let's see. So during dinner, people paid on average $3.10 of tip, and lunch $2.72. So people tip better during lunchtime. Okay, and now let's do some visualization here of my data. So let's say, for example, I want to do a histogram. So create a variable for it, and I want to do px, which is the nickname we gave for the Plotly Express, and we're going to call the histogram for px, pass in our data, which is df, we call it df, and who is going to be in the x? Let's put over days. So my x-axis will be the day. The y can be the tip. Okay, let me see. What do I have so far? Okay, so I have the tip here for Sunday, Saturday, Thursday, Friday, but it doesn't have any title. So I can put here a title, and we can call it tips per day. So this is the simplest histogram we can create, tips per day. So this is the sum of the tip. So we can see here the tip per day. Okay. And let's do one more here. Let's, for each one of these bars, let's add the time. For example, on Sunday, I want to divide this column into dinner and lunch. So how do I do that? Same procedure. px.histogram, put your data set, who's going to be your x-axis, who's going to be your y-axis, and then you can get here color. So my color will be time, which is lunch or dinner. So when I do that, notice that easily now I can see here that on Friday I have here lunch and I have dinner. On Thursday, people had more lunch than dinner. You see, dinner was just a small portion of my Thursday. So this is how I can plot a histogram where I have some parameter for the x, another parameter for the y, and I use the color to show me another parameter here, for example, time. Okay, you can choose sex, for example, as the color as well. So you can see that male and female. So I divide each one of the columns based on male and female, and the legend shows up to me here easily. So it depends on what do you prefer to show. Instead of the tip, you can put the total bill, right, as the y-axis. So you'll see here the sum of the total bill divided, represented across different days, and you can see it for different categories, for example, male and female. Okay, let's do one more before we go. We can do, for example, another histogram, and we can put smoker and non-smoker. So my X will be the smoker. And the Y can be the sum. We can keep the sum of the tips. So let's do tips here as my Y. We can call it tips per day. Oh, I didn't change the name here. This is the total bill. Total bill. Okay, tips per day. And the color here can be the party size. So let's use the other categorical value that we have here. And we can show the, there are two smokers, smoker and non-smoker. And in the y-axis, I can have the tip value. So you can see that the non-smoker tipped, there's a higher value for the tipping of non-smoker than smoker. And here I separate by the size party, okay? So it's incredible that obviously it's just we're adding the value. So this is size 2, size 3, 4, 6, and 5, okay? So simple plots using the histogram. You can also create a scatter plot. Similarly, you can call px.scatter, pass in my data, and the x can be, for example, the total bill. And I want to compare it. I want to correlate this with the tip. So let's see the relation between the bill value and the tip, okay? So if I do a simple plot like this, I'll be able to see the dispersion here. Okay, this is the total bill. So as the total bill increases, it's expected that the tip also increases. But you can see some high bills here. For example, this one was $44 and the tip was just $2, right? So this is what the scatter plot gives me. If you want to give it a title, you can give a title, okay? So this is a scatter plot of bills and tips. You can see here that there is a trend, obviously, that the higher the bill, the higher the tip, but you can find some elements that are outside this linear regression here, where you can have someone asked me to scroll up. Is the histogram one? Again, I'm only displaying two parameters here. I'm displaying the total bill and the tip. I can use color to help me. So if you want to convey and add another type of information, you can use the color to explain that. So we can say, for example, we can use the color to represent the sex. So you can do here, and you can see that there are two possible colors, one representing female and the other representing male. And you can see that information in our scatter plot. Okay, so these are some basic visualization. We're going to continue on this next class. Okay, there's still a lot that we can cover. Class time is very short. I wish we could stay here longer and cover more plots, but I'll make sure to show you more next class. And I'll give you an exercise so you can start working on this data. And if you're curious, our project, our midterm project is already out. It's based on what we've been doing every week. It's a recap of everything we've been doing since the beginning of the class. You're going to do a report on some data set. The rubric is here, groups up to 4 people, but I can talk about this more in person next week. Sounds good? Class passed really fast. I didn't expect it to move that fast. I can't believe it's already 3:15. But thank you so much for joining me on Zoom. I will post this video and let me know if you have any questions. Thank you.